Hey folks, welcome to Local Hack Day 2016. I'm Joe Nash from GitHub Education and I'm joined by Pandelis, one of the most prolific student hackers here in the UK. Pandelis is going to run you through some amazing Git workshop now and kind of give you an introduction to Git, why you might want to use it and how to go about doing that. But before we get started, just want to remind you all that if you do want to get started with Git or GitHub, you can access the Student Developer Pack for loads of free tools, including Amazon Web Services, GitHub obviously, Datadog, things to help you learn, all sorts of stuff at education.github.com/pack. So Pandelis, over to you.
Thank you. So I just want to briefly say, because I go to so many hackathons, one of the biggest barriers to starting work on your team is getting your environment set up.
Yeah, absolutely.
Just making sure everyone's on the same page and can contribute to your code base. So I'm just going to go over some of the basics in Git, some stuff that will be able to get everyone on your team up to speed. Once one person on the team knows these basics, you can just get everyone up to speed, teach them these little tips and tricks, and everyone can just contribute straight away to your local Hack Day hack.
Yeah, which, I mean, Local Hack Day, that's one of the most important things, helping new beginners to the tech world, to hackathons, get their start, and being able to collaborate with seasoned experts and use Git all together will help you make those 12 hours as productive as possible. So we're going to go ahead and switch over to an on-screen recording, and we're going to run through. If you do have any questions about this recording or any of the things we've been covering, you can jump into the Local Hack Day Slack and ask questions from the technical mentors on there. I expect Pandelis will be at a Local Hack Day.
Yep, I'm organising the Birmingham Local Hack Day this year.
Wicked, cool. See you on the other side.
So hey guys, so I'm just going to run you through my collaborating on code workshop. So working together shouldn't be so hard. There's a few options that you may attempt if this is your first time working collaboratively with some teammates on a shared code base. You may try to email each other your entire code as a zip file. You may choose to sync your working directory using some cloud provider like Dropbox or Google Drive. You may even try to copy and exchange it through FTP, or even, if it's more convenient, try some USB drives and just try and keep the up-to-date version between each other and just switch the USB drives out. Now, these are all methods that should not be used. They're very bad for collaborating. Because you don't have a shared version, you don't know who has the most up-to-date version because you're both working on the code at the same time, and there's no way to go back to a different version, and you don't really have any backups. You only have this one copy that's on either your own computer or the USB stick, or having sync issues with Dropbox. So what we're going to go through is collaborating the right way, the Git way. So this lesson's based on the Pro Git book by Scott, Chacon, and Ben. You can find this online for free through the Git SCM website if you want to go more in depth into what we're going to talk about today. So let's start with what exactly is this Git thing. So Git is a distributed version control system. Now, what distributed means is the code exists in multiple locations. So not just you, but your collaborator and also GitHub.com have their own versions. And version control means that at any time the code can be reverted back to a previous state. Now, digging more into what this distributed means. So the shared nature of Git means that every developer can have their own complete isolated version of the code, completely freely distributed across every contributor, every member of your team. So each developer has a completely sandboxed version, and they can do within that working directory on their own computer, they can make as many changes as they want in whatever form best suits their development style. And then finally, when it comes to the time to commit those changes or push those changes up to the shared repository, they can then adapt their code, and everyone else can then pull down those changes to their own working directory in whatever fashion and at whatever time best suits them when or throughout their developing process. So for example, if this developer over here wanted to make a change, he could just simply download the repository, have his own copy, make changes, and then at the same time, another developer could download the repository, make changes, and be confident that Git would manage that efficiently, and there wouldn't be too much hassle when you go to merge those changes that you both make together. So that's the distributed nature of Git. Everyone has their own version of the code that they can work on in their own isolated environment. Now, Git is used by a lot of big tech firms to manage their all their products and code. So that's why we're going to look at Git today. It's very popular among developers, and it's proven to work very well. So developers like Google and Facebook and Microsoft openly use and embrace Git. So how Git works, now Git has a few main states that your files can reside in, and once you get your head around these, this wording and this way of thinking, you'll be able to use Git quite efficiently. Just bear with me as I just explain this briefly, and then we'll move into a demo of the Git commands, and you'll much better understand what all this means. But before we start, I do need to explain what these actually mean. So your Git workflow looks a bit like this. You can have a file residing in a committed state, a modified state, or a staged state. Now, committed means that your data is safely stored in your local database. So you've taken your code, you've made changes to it, and you've locked in those changes. You've now committed them to your local database, and they're locked in as your final changes. And you can attach a message to them so that you can track your changes as you go along. And you can revert back to these changes or forward in time into other people's changes based on these commits. So commits are exactly how Git will track each version of each file and each change. Now, the modified state means that you have changed the file, and Git has detected that you've changed that file, but you've yet to commit it to your database. And finally, a staged file means that you've marked a modified file in its current version to go into the next commit snapshot. Now, what that means is you've made a change to one or more files, and you've bundled them into a staging area, and you're getting ready to then commit them. So the staging area is what comes before your final commit. You add files to the staging area, and then finally you bundle them up in a commit, and you lock those changes in. This is what this flow looks like a bit more graphically. So each developer, as we saw before, they have a working directory, and this is unique to every developer. They have their own version isolated from everyone else, and they can do in the working directory anything they desire, or anything that they have to do to develop efficiently on the code. So the working directory, you can take a file, and when you make a change, you can add it to the staging area. And you can add more than one file to the staging area. And when you're ready with that change, when you've modified the files that you need to modify to implement the feature or add a new entry to a file, you can then commit it. And that commit locks in those changes and will add it to your local Git directory. And then from here, you can then push it up to master or push it up to the remote Git, and then other developers or other contributors can pull those changes down from that remote Git server. But this can't be done without you first going through these stages of staging a file, committing it, and then finally pushing it. A bit more in depth now. These are, once again, the files, some of the states that your files can exist in. We can have untracked files, unmodified files, modified and staged files. Now, if we take a file that already existed, for example, it will exist in an unmodified state. Then when we edit the contents of that file, Git will detect it's changed, it will flag it as modified, and we can then take this modified file and add it to the staging area. From this staging area, we can then make a commit, and that commit will save that to our local Git, and that change will now be locked in. The file then returns to an unmodified state, and we can then rinse and repeat. We can continue doing this until we're happy with our changes, and then we can finally push these up to master for all our other collaborators to then download and explore that code. So there's a lot of different ways we can use Git. There's a lot of GUI tools like the GitHub client. There's Git Kraken available from the GitHub education pack. and other such GUI interfaces, but today we're going to only look at the command line. And that's because the command line is actually all the Git tools that you could ever have. They're all built into the command line, and these GUI clients actually just use that command line in the background to do everything that they do. And so it's good to understand the exact commands that are being entered, and also these commands are universal across every machine because the Git tooling is exactly the same across Linux, Windows, and Mac. And Windows users, I'd recommend you install Git Bash. So that's at git-for-windows.github.io. That will install all the tools that you need to actually run Git in the command line on your Windows machine. So some of the basic commands. You can git init to initialize a local Git repository. Or alternatively, if we're using a remote host like GitHub, we can git clone from a remote path, and that will bring down those Git files and create a working directory on our own machine, like we saw in the diagram previously, and we'll have a complete new copy of that code on our machine. Now diving into some of the meat of Git, we have the git add command, and git add will add a file to our staging area. Git commit will then take those staged changes and commit them to our local repository. Now this tac-m and commit message here, this is how we enter a commit message or attach a message to our change. So as we move along, as we change code, we can message it, we can append a description to our changes so that we can track how our code adapts, and we can move back and forth and understand how our code has developed over time. So if, for example, down the road, we make a change and it breaks one of our features, we can simply go back in time using the commit messages. We can know exactly what changed, and we can revert back to a working state. So if you're using USBs or email, for example, or a shared drive, for example, to share your code, you wouldn't be able to go back in time like this because you would only have one version of the code. Whereas in Git, we track every change, and you can move backwards in time effectively. Finally, git push will push those local changes you have in your Git to the remote host like GitHub, where other developers can then download those changes and explore your code. Now, one more time. So the working directory, if we do a git add command, this will stage the files to the staging area. We can then do git commit and then append a message, and that will add it to the Git directory. And from the Git directory, we can then push that up to our remote branch or remote repository. Right, now let's dive into a demo and actually understand how this works. Cool, so this is my terminal. And before I start, I'm going to go to my GitHub page, and I'm going to create a new repository. So I'm just going to go to github.com and create a new repository. I'm going to call this my local hack day hack. And I can append a description. I'm going to keep this public, and I'm just going to hit create repository. And I can now take this URL that GitHub gives me, and I can enter the first command that we learned. So we can do, I'm first going to change into my temporary directory. I'm going to do a git clone now, and I'm going to paste in that remote URL, and Git is now going to clone that into my local directory. So I'm now going to change into that. And we now see, if we do an ls-a, we have a .git file, and this is what is going to track all our changes as we go along. So I'm going to create a file, and I'm going to call it animals.txt. And I'm going to open this up in Atom so that we can make some changes. So here's my animal.txt. Currently there's nothing in this file, but I will now go ahead and add cats to this file. I'm going to hit Control S to save it. And let's resize this over here. If I now do a git status on this folder, we can see that we now have an untracked file. So if we look back to what we were discussing earlier, we have these states of being untracked or unchanged, changed or modified, and finally a staged file. So this is currently untracked. So to add this file to our staging area, we will simply do a git add. So I can do git add the name of the file. And if we now do a git status, we can see this has been added to the staging area. So it says changes to be committed. So this is yet to be committed, which means it's now in the staging area. To add this to the staging area, we use the git commit command. So from before, git commit tac m, and we'll be able to add a message. And within here, we'll say created animals.txt. So I'm trying to be as descriptive as possible so that in future, I can know exactly what commit, what I did at each commit. So I did two things here. I created animals.txt and I added cats. So that's super descriptive. I know exactly what happened there. And if we now do another git status, we can see we are now in an unchanged state. So we've now committed this, we've locked in these changes, and now Git thinks, okay, everything's fine. We're up to date. There's nothing that's changed because we've locked in those changes and we said, no, this is the most up-to-date version, and we've committed those in. Now I'm going to switch over to my remote Git and refresh this page. And we can see there's nothing actually on my remote Git. That's because I've simply saved these changes to my local Git. As we discussed in the beginning, every developer, everyone in your team has their own complete unique copy of the code. It's completely sandboxed from everyone else and they can do with it what they wish. So we've yet to push this up to the remote server. It's simply on our own working directory. So we have our own code, and to share it with everyone else, we're going to use the last command that we learned, the git push command, and we're going to tell it to push to the origin, which is this remote location here. And we're going to push it to a special branch called master. Hit enter. And we're going to see git write these objects, and we're going to see to GitHub updated. And if we switch back to GitHub and refresh this, there we go. We now have an animals.txt. So we've now shared our commit up to everyone who might be working with us. So just to simulate other people working with us on this file, I'm going to open up another terminal. And I've colored this terminal white so that you guys know this is another user. And I'm going to clone down my local Hackday hack. So I'm in my temporary directory again. I'm going to execute the same command again, but this time I'll add it to a different directory. It's now going to clone it into that directory. And if I now also open this up in Atom, so I now have two completely isolated versions of the code open on my computer. So now I have two unique working directories, as if I was on two completely different computers. So if my teammate wanted to add another animal to this file, let's see how he would go about doing that. So I've now downloaded it. Let's add a dog to accompany this cat. And let's go through the same motions again. Let's do a git add on this machine. To add all the files in my current directory, I can simply do a dot, and that will add all the changed files. So I'm going to do git add dot. I'm going to then commit it. Again, I'm going to use a descriptive message, added dog to animals.txt. And if we check the status again, we can see we're now up to date. And we can see your branch is actually ahead by 1 commit. So Git has detected that we are now ahead of the remote branch, and we should probably now push this up so that our other teammate can download it. Because as we can see, this original terminal window and this original Atom window do not have that dog change currently. So let's push this to origin master as we've made this change. That will now write those out. And if we come back to our other window, we can see we still do not have that change. The reason is we have full control over this working directory, so we can choose when to pull down new changes. We know a change has happened, so let's go ahead and do a git pull, and that will pull down all changes from the master branch that have happened. So git pull, that will go ahead and pull down, and we can see on the right, dog has now appeared in my file. So that's how easy it is for people to work on a file on GitHub. Now, it's not always this easy. Especially if you're new to Git, you may come across a merge conflict. And what that means is that someone has edited something in a file that has overwritten the remote branch. Or you make changes to a file at the same time, and Git gets confused as to which one is correct. So for example, if below cats, I'll add a gorilla in this file. And if below cats in this file, so this is a completely different directory once again, I'll add a cow. And let's go ahead and commit these on both these repositories. So I'm going to git add dot, so that's now stage this. As modified, git commit -m added gorilla, and here let's do a git add and git commit -m added cow. So now if I try to git pull the remote changes in this directory, we will have a merge conflict, but first I need to push them from here. Git push origin master, and now we'll attempt to pull. Now we see in our terminal we have a git merge failed, and over in our file, GitHub or Git has gone ahead and highlighted exactly where that conflict exists. We can see this head pointer pointing to the remote head, and we can see that gorilla has been added here in the remote file. So I know that I want to resolve this conflict and I can simply just remove these pointers out the way. And I've now resolved this conflict. But to fully resolve this, I need to add this now to the staging area, commit that as resolved the gorilla conflict. I can then push this up to master. And then finally, the original gorilla pusher can then git pull this down, and we are both at the same state with the same file once again. So now that we understand the basic features of Git and how to add to our staging area, commit and save those changes, and then push them to our remote branches or our remote repositories, let's briefly look at some best practices and working with branches. So in general, we want to keep the master branch as what we call the source of truth. And what that means is the master branch will always contain the most up-to-date version of our code that works. So if you were to, for instance, add a new feature to your program that could potentially break your code, you'd want to implement it as a branch first, and then merge that into master when you know that it works. So to work with branches, let's switch back over to our 2 users here, and let's create a new feature. So this animals.txt currently exists simply as a txt, but as a new feature, I want to make this a JSON file. So to do that, let's use branches. because this is a brand new feature and I'm not sure if this will work, I'm going to go ahead and do a git checkout tag b and name this JSON. So I'm going to create a new, this will create a new branch with the name JSON. And it will automatically switch me into this branch. Now in Atom, I'm going to create a new file. I'm going to save this as animals.json. And I'm going to start creating my data. So this is going to be in the JSON data type. I'm going to call this animal cat. Save this, and I'm going to go through all the steps as I do normally in a standard Git. I'm going to add this to my staging area. I'm going to commit these changes. Added animals.json. And now this exists as a change on this branch. And now instead of pushing this to the remote origin, I'm going to git push origin JSON. And now if I switch back to my GitHub page, and if I look at branches, I can see a new JSON branch has been created. And GitHub will auto detect that branch as being created and tell me to pull request, open up a pull request to merge this back in. Now I don't have to do this because this this is my own repository. But if you're working on someone else's code or someone else's repository, you would go about making a pull request. But for this demo, we don't have to do that. So to merge this change into master now, I simply have to change into master from this repository. So I'm going to change into master by doing a git branch master. Or excuse me, I need to git checkout into master. And now we can see we've gone back to Atom has updated over here and we don't have that file. But to get that from that branch, we need to merge it in. And to do that, we do a git merge and the name of the branch, which is JSON. And we can see over in Atom that file has been added. And we can now, to update our master online, if we double check, this is yet to be pushed up. So we simply have to do a git push origin master. That will now push it up to Git. And if I refresh this page, we now have animals.json in our master branch from our branch. And if we take a look at our GitHub page, we can actually see how this code has adapted over time. So we can go into our code, we can see every commit, every version of the code, and if we wanted to, we could go back and forth between these versions. So we simply have a version here, and we can keep those versions backed up, and we are confident that we always have a working version. So that's everything I wanted to talk about branches, and that's enough for you to now be able to make your own Git repo, make changes, commit those changes, and then add new features on branches, and then resolve any conflicts that you might have merging those branches in. If you want to find any more details about the tools that we used today, you can once again revisit that book on the Git SCM, or try out some of these basic Git commands on try.github.io. Or also, Joe has a recommendation for some more advanced Git training.
So Git It is a desktop app built on Electron that walks through everything you need to use Git for your projects, both on the command line and on GitHub. It's a lovely little desktop app that works on cross-platforms. You can go ahead to the repo and install that. It was built by a former GitHubber, and it's a really nice little guided course through everything that Pandelis has covered in today's tutorial. So other than that, happy hacking. That's goodbye from me.
And goodbye from me. Thank you.